Hey everyone, welcome to The Explainer. I am super thrilled you're here today. We're going to take a really fun journey back to the early days of modern computing. We're looking at a huge breakthrough that literally changed how we interact with information. You know how your absolute favorite teacher just gets you? They anticipate your questions and guide you perfectly? Well, today we're going to explore how early software engineers taught computers to do exactly that. So think of me as your mentor for this session as we decode the incredible blueprint that makes digital learning actually work. Let's get right into it. Okay, picture this. It's 11 p.m., you've got a massive term paper due tomorrow morning, and you know the exact answer you need is buried somewhere inside a colossal 1,000-page, completely boring textbook sitting right there on your desk. Obviously, you're not going to read the whole thing. You just want the specific answer to your very specific question. It's a totally universal student struggle, right? I mean, we've all been there, frantically flipping through an index at midnight, trying to find that one golden needle in a giant haystack of text. So let's look at this fundamental problem. Think about that giant, heavy biology textbook in your backpack. That book is what we call linear text. The author forces you to read chapter 1 before chapter 2. They dictate the exact sequence. But honestly, that completely clashes with a reader's needs. Because as a student, your brain doesn't always work in a straight line. You might be reading a paragraph about a cell wall and suddenly wonder, wait, what happens if this cell gets a virus? You want to jump directly to your specific interest and get an immediate answer. Linear text, it completely fails to satisfy that natural, curious urge. To solve this rigid textbook problem, computer scientists developed something called basic hypertext. Now, you use this literally every single day when you click a blue link on a web page. It's just a non-linear arrangement of text linked by key phrases. But in the early days, hypertext was incredibly chaotic. Imagine your classroom bulletin board, but covered in random sticky notes, all connected by tangled pieces of string. Or think of a giant choose-your-own-adventure book, where clicking a highlighted word just drops you onto a totally new page with zero context. It was a revolutionary idea for sure, but man, it was incredibly messy. This early hypertext had two massive fatal flaws. First up, the loss of coherence. You'd click a link, get teleported to a totally new page, and instantly lose your train of thought. You'd just be sitting there like, wait, how did I even get here? The second flaw was the lack of semantics, which is honestly just a fancy way of saying the links had absolutely no real meaning attached to them. This is the indexing problem. A link might say competitive advantage, but it doesn't tell you why it's a link. Does the next page define the term? Does it give an example? Argue against it? The links had no inherent meaning, which left the reader totally flying blind before they click. So, how do we fix all this chaos? Well, let me ask you a question. What if a computer system didn't just give you random, blind links, but actually anticipated your questions like a brilliant mentor? Think of that one teacher you have who just knows exactly what you're going to ask before you even raise your hand, and they immediately point you to the exact paragraph you need. That exact metaphor is what brings us to a massive computing breakthrough. Way back in 1994, which is ancient history in internet time, a researcher named Richard Osgood at Northwestern University published this monumental dissertation. He wanted to solve the chaos of the early internet by completely rethinking how we index and retrieve information. His main goal? To bridge the gap between a static, boring textbook and a dynamic, engaging conversation. To do this, Osgood introduced a concept called Conversational Hypertext. Instead of just linking the phrase George Washington to another article about George Washington, Conversational Hypertext structures nonlinear text around anticipated reader questions. It completely flips the script. It was a true paradigm shift. Instead of handing you a whole 1,000-page book and saying, yeah, good luck, the system actually listens to your virtual question and hands you the exact paragraph that answers it. And to prove this actually worked, Osgood and his team built a real piece of software called Ask Michael. I want you to think of it as the ultimate 1990s digital study guide. They took an incredibly dense, complex economics book, Michael Porter's The Competitive Advantage of Nations, and completely restructured it. They transformed it from a heavy, linear textbook into an interactive question-and-answer dialogue. Let's take a look at how this actually worked in practice. Check this out. This is the actual 1994 interface for Ask Michael. Imagine this as your own high-tech, interactive study desk. Right in the center, you have the text you're currently reading, and surrounding it are these distinct stacks of cards. Okay, yeah, it definitely looks a little retro to us right now, but at the time, this was a fundamentally new way to experience reading on a screen. So imagine sitting at this screen. You read a central passage right in the middle. As a question naturally pops into your head, instead of searching blindly, you just look to the margins. This system has already anticipated your curiosity and populated those margins with relevant question cards. You simply click a card on the side to dig deeper into a related topic. Plus, there's a navigation pad for zooming out to broader themes, and a full-text search just in case you need it. The whole experience is entirely guided by your own curiosity. But, as you might guess, this raises a massive technical problem. An entire textbook generates thousands and thousands of potential questions. So how does a computer perfectly organize all these questions so you never get overwhelmed? I mean, if you just dump 500 questions on a screen, you're right back to that chaotic bulletin board problem we talked about earlier. To solve this, Osgood utilized 8 specific conversational association categories. Think of these as the ultimate color-coded study deck. Every single question is categorized by its conversational purpose. So if you want an explanation, you look at the causes or results cards. If you want a comparison, you look at the analogies or alternatives cards. And if you need application, well, you look for warnings or opportunities. By perfectly sorting the anticipated questions into these fixed categories, the system beautifully matches how human logic and conversation naturally flow. This brilliantly illustrates how those exact categories look in action. Notice how, under the causes category, the system explicitly asks, why are letterpress printing presses useless in Japan? By presenting a logical question right there, rather than just a blind hyperlink, the software bridges 2 totally separate pieces of text. You always know exactly why you're clicking, which completely solves that coherence problem. You never, ever lose your train of thought. So from a user perspective, it's this smooth, mentor-guided experience. But let's geek under the hood for a second. How do programmers actually build this question-answering machine? How do you take a static block of text and magically turn it into this incredibly smart, responsive network? Well, the secret sauce is a process called question-based indexing. This was a super meticulous, step-by-step method of linking text. It works by matching the specific questions that one passage raises in a reader's mind with the exact passages in the database that answer those questions. Imagine mapping out a giant interconnected web of logic. You really have to appreciate how incredibly labor-intensive this was for programmers in the 90s. They were doing all of this manually without modern AI to map it out for them. But the result is a system that feels totally alive and responsive. This all comes together in a simple 4-step recipe. First up is preparation, figuring out the audience. Second is content analysis, chopping the book up into segments and listing out what questions each segment raises and answers. Third is question classification, sorting those questions into our 8 color-coded conversational categories. And finally, question linking, literally drawing the digital wires that connect the raised questions to the answered ones. I actually want to pause on step 1 for a second because it's absolutely fascinating. This wasn't just cold, hard code. That preparation step literally required the human indexers to use their imagination and role play. To build the system, the programmer had to sit back, pretend to be a curious, stressed-out student, and guess exactly what weird, specific questions that student would naturally ask while reading a given paragraph. It put the human element right at the dead center of the computer science. So what was the result of all this intense labor? Basically, 4 massive upgrades to how we read. 1, it enables a true question and answer dialogue with the machine. 2, it maintains your reading coherence. You're never getting lost in some random wiki rabbit hole. 3, it satisfies entirely diverse reader interests, letting you follow the path you actually care about. And 4, it actively generates interest. I mean, if you see a card asking a wild question you hadn't even thought of, you're going to click it. It really makes learning addictive. Which leads us perfectly to the core philosophy of Osgood's entire 1994 project. He said, restructuring a book as a question-based hypertext can improve text understanding. By taking that rigid, linear textbook and shattering it into a beautifully mapped web of human curiosity, we didn't just make the book easier to read, we made the actual comprehension of complex ideas fundamentally better. We literally taught information systems to think in conversations. And that brings us right back to today. Think about the digital tools you carry in your pockets right now. When you type a question into a modern search engine, or when you chat with an advanced AI on your phone, they are doing exactly this, anticipating your intent, categorizing your query, and delivering the specific conversational answer you need, rather than just throwing a whole massive library at you. So my final question for you to take away from this explainer is, where else do you see this 1994 conversational blueprint actively shaping the technology you rely on every single day? Keep that in mind next time you're searching for an answer online. Thanks so much for learning with me today.